So in example 4, we're forming another confidence interval from the same data in example 1. So from example 1, we do already know that our X bar is 21.1 and that our sigma wasn't given in example 1, but it was given when we found the margin of error as 2.3 hours. Sigma is equal to 2.3 hours. We did use that when we found the margin of error for the 95% confidence interval. But sigma shouldn't be changing. Sigma will not be changing. Wait, what was it? Okay, so sigma is 2.3. So what we need now, because remember, we're going to do, for the confidence interval, we're going to do X bar minus E, and we're going to do X bar plus E. But we do need E, which is equal to Z sub C sigma over the square root of N. In example 1, they also did have a sample size of 40. So we have everything we need except for Z sub C for a 99% confidence interval. So I'm going to just pop over to the standard table and look for the level of confidence for a 99% confidence interval, and that's 2.575. Notice that it is bigger. It goes further out because you're being more confident. The more values you include, the more confident you can be. So we have 2.575. Okay, so let's plug these in to calculate our error. 2.575 times 2.3 divided by the square root of 40. So this comes out to be about 0.93643. And I'll just leave that rounded to 5 decimal places. So then I'm going to come in here and take my sample mean and subtract the error that we just found. And then I'm also going to come in and take my sample mean 21.1 and add the error that we found to find the upper bound for this confidence interval. And then the upper limit I find to be 22.03643. So now we have constructed a 99% confidence interval. So the interpretation for this would be very similar to this interpretation, except we would start off this time and we would say with 99% confidence that the population mean number of hours that is spent on required athletic activities is between 20.16 and 22.03. I think I said 20.03, but I don't know what I said. I meant 22.03 if I didn't say that for the upper limit, and that is in hours. So there is our interpretation. You will be doing a very similar example here in try it number 4, where you're constructing a 90% confidence interval. So be careful, because the 90% tells you what to look for when you go to find your critical value Z sub C using the standard normal tables down here, specifically that little piece down there at the bottom. And do make sure that you are still using the data from example 1. Do make sure that you're still using the data from example 1, from the original example 1, so the same data that we used in example 4. So you're not using the try it, use the example 1 data.